Right, guys, this is a complete review on Unit 3 based on the College Board curriculum of AB Calc. It doesn't really matter if you are taking AB or BC because these are identical. I'll be walking you through lots of questions. These are based on the topics, all the topics that are covered in this particular unit. As always, you can download this worksheet from the link in the description. If you need private tutoring, feel free to reach out. All right, first question, we need to find dy over dx of each of this. So it looks like we have to use the chain rule, right? So dy over dx is going to be chain is always, I always think of chain rule as breaking stuff. So when you are breaking sine of 2x, first you break sine. Break means differentiate. So derivative of sine is cosine and the inside guy remains as it is. And then you break 2x and the derivative of 2x is just 2, right? But we are not done yet. What is the formula for a to the something? Usually students forget that. It's a to the something is a to the something natural log of the base times the derivative of the power. That's how the derivative works over here. So let's decorate this. It can be written as 2 cosine 2x, yeah? And the derivative of sine is cosine, of course. So the answer is 2 to the sine x times ln 2 times cosine of x. So that's going to be our final answer. Okay, be careful in question number 9. The log is with a different base, right? At the base of 9. So I would recommend that in the log questions, always try to see how much you can simplify the question itself without before differentiating it. For example, I know right off the bat that this power will be thrown outside as per the properties of log. So it can be written as 5 times log with base 9 of 6x to the power 4 plus 3. And now I'm gonna use the change of base formula because the formula for derivative is available only for log as in a default base of 10 or natural log, right? Not for anything else. So I'm going to rewrite this as natural log of 6x to the 4 plus 3 over natural log of 9, right? I'm just rewriting the question. I'm not differentiating anything right now. And now if I want to differentiate, obviously the 5 over ln 9 has nothing to do with the derivative. So I'm gonna, write it together so that in the immediate next step, I'm just going to take it out because that's a constant. So if I want to find g prime x, like I said, 5 over ln 9 sits outside. The derivative of ln is 1 over the inside thing. So it'll be 1 over 6x to the 4 plus 3. But we are not done yet. We need to use chain rule. So we go inside and break this stuff up. So derivative of 6x to the 4 plus 3 will be 6 times, and derivative of x to the 4 will be 4x cube, and derivative of 3 is just 0. So I'm not going to write that. So finally the answer is 5 times 4 is 20. 20 times 6 is 120. So it's 120 x cube over ln 9 multiplied by 6x to the 4 plus 3. That is going to be our final answer. Okay. Question 3 should be easy, I think. How we can rewrite, how we can differentiate it right now is just by, taking the, applying the rule that a raised to something is just a raised to something times natural log of the base times the derivative of the power, and the derivative of x squared minus 1 minus 7, if you understand it directly, it's just 2x because 7 is just 0. So it's actually 2x minus 0, but there's no need to write that zeros, and I don't think so I need to simplify that. That is my answer. Okay. Let's try to differentiate this one. So f prime, this is thankfully just the natural log. So it's just 1 over the inside guy, which is 4x cubed plus secant of x. But I'm not done yet. I'll go inside and differentiate this entire thing. Derivative of 4x cubed will be 4 remains as it is. And derivative of x cubed will be power rule. So 3x squared, and derivative of secant x is secant x multiplied by tangent of x, right? And I don't think so we can simplify. I mean, we can write 4 times 3 as 12. I'll do that for you. 12x squared plus secant x tangent x divided by 4x cube plus secant of x. So that should be our final answer, I think. Okay, question 5, I need to use the product rule followed by a hidden chain rule, right? Should not be that bad. Let's apply the product rule first. So dy over dx is going to be, the first term remains as it is. So let's say x squared plus 1 cube remains as it is. You could have taken this one as it is as well. It doesn't really matter. The order is irrelevant. And then we differentiate this one. Now be careful here. We need to apply the chain rule. So first, this is protected by the power. So we need to apply the power rule. So 5 comes down and it will become 4x plus 3 to the power of 4. Then we go inside and differentiate 4x plus 3, and derivative of 4x plus 3 is just 4. Plus, then 4x plus 3 to the 5 remains as it is. And then we differentiate this guy, which is once again a power rule and then chain rule. So power chain rule. So 3 comes down and then it is x squared plus 1 square. And then the derivative of x squared plus 1 is 2x. Finally, 5 times 4 is 20. So I can write it as 20 times x squared plus 1 cube and then 4x plus 3 to the power of 4. Plus 3 times 2x is 6x, and then 6x times x squared plus 1 whole square, and 4x plus 3 whole to the 5. So that should be our final answer. Okay, another one we have, question number 6 is, once again guys, whenever I see a log, I have a tendency to always check whether I can simplify it further or not, and it looks like I can simplify it, because natural log of 4x, root of 4x plus 2 can be written as 4x plus 2 raised to 1/2, and log has a property that if inside guy is raised to a power, then the power is thrown outside. So this will look like secant of 5 raised to 2x plus 1 over 2 drops outside, and then natural log of 4x plus 2. So I'm going to differentiate this now. G prime will be, what is the derivative of secant? Secant is secant of that something, tangent times tangent of the something, tangent of the 5 raised to 2x. But I'm not done yet. I need to differentiate this inside guy as well using the chain rule. So 5 to the 2x derivative is just 5 to the 2x times natural log of the base, which is natural log of 5. But again, we are not done yet. We need to differentiate the power as well, which is 2x, so derivative of 2x is just 2. Oh, plus 1/2 remains as it is. Derivative of natural log is 1 over the inside thing, so 1 over 4x plus 2. But I'm not done yet, then I'll differentiate 4x plus 2, which is just 4 over here. Obviously, you can do 2 times 2 is 4, but other than that, I don't really think so you can simplify anything else. So yeah, that's about it. That's my answer. Okay, and we're talking about at what point on this graph is the tangent line parallel to the line this. Okay, tangent line parallel means what? We need to compare the slopes, and parallel lines means equal slope. So I'm looking for the slope of this function at that point. Should be same as the slope of this, and thankfully this is y equal to mx plus b form, so the slope is just 2. And what is slope, guys? Isn't that just the derivative? So I am looking for the point x, or they are asking points, so maybe they want x and y both. I can give them both, where dy over dx is equal to 2. Let's differentiate 4 to the x plus 3. So obviously derivative will be 4 to the x times natural log of 4, and derivative of 3 is just 0, so I don't really care about that. So that should be equal to 2, which means that 4 to the x should be equal to 2 over natural log of 4. And well, that's a little weird, because if I need x, I'll just take natural log both the sides. So natural log of 4 to the x is equal to natural log of 2 over natural log of 4. Too many lns over here, but yeah, the x drops down. So this can be written as x times natural log of 4 is equal to natural log of 2 over natural log of 4. Oh my god, that's extremely gross. But yeah, finally I'm going to divide both sides with natural log of 4. So answer is 1 over natural log of 4 times natural log of 2 over natural log of 4. Obviously, if the calculator is allowed, you can just find that. But at the moment, I'm just going to stop at x. I don't think so. I want to put that back in and find y. I think I'm happy with x. Okay. Implicit derivative. So we are given an equation and we need to find a single and double derivative both. So let's differentiate this right away. Derivative of 2x square is going to be 2 times 2x, because 2 remains as it is and derivative of x square is 2x. Here usually students get confused when I just write, they say it should just be 2y. Remember, we are differentiating in terms of x, not y. So we want to find what is d over dx of y square. So derivative of y square will be 2y, of course, using the power rule, but using the chain rule, you need to go inside and differentiate this y as well, because right now you just differentiated the power. But when you differentiate the inside guy, you cannot really differentiate. You just have to end at dy over dx. So it's not just 2y, it's 2y dy over dx, and the right thing is not just 1, that's 0, because derivative of constant is 0. So this will become 4x. Let's move this on the right side of the equation. So 2y dy over dx. Let's divide both sides by 2. So 2x is equal to y dy over dx. And dividing both sides by y, I have dy over dx as 2y over x over here. So that's my part A, which is dy over dx is equal to 2x over y. Now I need d square y over dx square. So let's differentiate this again, but be careful. You need to apply quotient rule and then be careful again, because that's an implicit differentiation. So quotient rule, first off, I'm going to take 2 outside because this innocent guy has nothing to do with the derivative. It's a constant multiplied with the variable. It's going to come out. And then I will say low square, low d high means derivative of high, which is 1. Because derivative of x with respect to x is 1, minus high is x, d low. Now remember, this is not 1. This will not be 1. D low will be dy over dx, because again, we are differentiating with respect to x. Students ask me, can we leave here? No, because your answer is in terms of another dy over dx. That's not allowed. You have to simplify. They are very categorically saying that you have to simplify in terms of x and y. So we are going to replace this dy over dx again by 2x over y. And then we are going to take the pain and simplify this. So this will be over y square remains as it is. The common denominator is y. This will become y square minus 2x square. I hope you are able to follow. And then keep change flip will make this y and y square multiply. So it will become 2 times y square minus 2x square over y cube. And that should be my final answer for the double derivative. Right, I hope this makes sense. All right, guys, if you're finding this video helpful so far, by the way, please like and subscribe. Please share it. Really help my channel, really help the other students as well. And if you need private tutoring, feel free to reach out. Here we need to find the equation of tangent and normal lines to this curve at this point. So obviously I have a point, I need slope. Slope is the derivative. So I need to differentiate this guy and find dy over dx to get the tangent, slope of the tangent. So x square y square is equal to 16. You know what? I can differentiate it right away. I have to use a product rule, or you can be a little smart and move 16, divide 16 on both the sides and do it that way as well. Honestly, I'll just do it with the product rule because I think the other method might confuse you. Okay, so product rule would mean that x square remains as it is. Derivative of y square, again, I already explained this earlier, it's 2y dy over dx. And then y square remains as it is, and the derivative of x square is just 2x. And that is equal to 0. Okay. I'm not really going to take the effort of isolating dy over dx, at least now, because I have a point. So it's better to simplify when I have numbers than I have variables. So I'm just going to replace x by -1. So -1 square and y by 4. So let's do all that. y by 4, x by negative 1 equal to 0. Negative 1 square is 1, 4 times 2 is 8, 8 times dy over dx, minus 4 square is 16, 16 times 2 is 32 is equal to 0. This means that 8 dy over dx is 32, and fortunately 8 times 4 is 32. So the slope of the tangent is 4, which means that I have the equation as well, because the point is negative 1 comma 4. So the equation that I have is y minus y1 equal to m times x minus minus 1, which will just become 1. It's okay to leave it like that. Even in APs, they are going to give you full credit. No need to convert in slope intercept. Yeah, slope intercept form. They need a normal as well. Normal is nothing but the negative reciprocal. Normal slope is nothing but the negative reciprocal of this guy's slope. So its slope will be negative 1 over 4 for the normal. So the equation is going to be y minus, what was the point again? 1 comma 4. 4 equal to negative 1 over 4 x minus minus 1 or x plus 1. So that is going to be the equation of the normal. Alright guys, we have an FRQ style question. We are given a curve and we need to prove that dy over dx is this. So let's do that. This is again implicit. So derivative of y square is going to be 2y dy over dx. If you don't mind, I'll write dy over dx and y prime. Very lazy. So in x square y, I'm going to write x square as, product rule. So x square times y prime and then y as it is, and derivative of x square is 2x, and that is equal to not 6. That will be 0. So 2y prime, I'm going to open up the parentheses, minus x square y prime minus 2xy is equal to 0. So 2y prime minus x square y prime is equal to 2xy. I'm going to take y prime as a factor. So 2y minus x square is equal to 2xy. So y prime finally, which is also known as dy over dx, is equal to 2xy divided by 2y minus x squared, which is exactly what I wanted to prove. Okay. Then they're asking that find the equation of a line tangent to the curve. Well, that's pretty straightforward. They have given a point. I'm going to plug that point over here to get the slope. So dy over dx will be replacing x by 1, y by 3, again y by 3, x by 1. So it will be 6 over 6 minus 1, which is 6 over 5. So the equation of the line tangent will be y minus 3 equal to 6 over 5 x minus 1. That's going to be the equation of the tangent line. Now they're saying that show that there is a point P with the x coordinate 0 at which the line tangent to the curve P is horizontal, and find the y coordinate of the point P. Don't you think that makes sense? I mean, see, if the line tangent is supposed to be horizontal, obviously its slope is supposed to be 0. And the slope is 0 means what? Dy over dx is 0. A dy over dx should be 0. This means that 2xy over 2y minus x squared should be 0, which means that the top should be 0, right? So 2xy should be 0. So obviously one possibility is when x is 0, and one possibility is when y is 0. I don't really care about y equal to 0 because they are just saying that prove that the x coordinate is 0. So obviously x coordinate equal to 0 is definitely a possibility. And they're asking find the corresponding y coordinate. So all I need to do is plug in this x coordinate, x equal to 0, in the original equation and find the y. So this is going to look like y square minus 0 equal to 6. So y will be, although I want to say plus minus root 6, but I'll just say root 6 because I see the note here that y is greater than 0. So the answer is 0 comma square root of 6. That's the point. Okay, and finally, they want, oh my goodness, they need the value of d square y over dx square at the same point. And that's going to be fun. So we need to find the d square y over dx square, which involves a quotient and then chain and product. I don't know how many rules are there. So quotient rule is the first thing. I think I'm going to need more space. So I'm going to differentiate this and use the quotient rule first. So it will be low square 2y minus x square square. Low d high. When I differentiate 2xy, I need to use the product rule. So 2x remains as it is and the derivative of y is y prime. And then y remains as it is and derivative of 2x is just 2. Minus high d low, so high is 2xy and derivative of low will be the derivative of this one. So it will be 2y prime minus 2x. That's the thing. Don't again make the mistake of simplifying the expression because they need at a particular point. The point is p and p is 0 comma root 6, right? So I just have to plug in x as 0, which is beautiful, and y as root 6, because if I put x as 0, then lots of things will just disappear. So let's put x as 0 first and see what are we left with. So this is 0 plus 2y minus, oh my goodness, great, x is 0, the entire thing is gone. This is 2y whole square. 2y times 2y is 4y square, and this is also, oh my goodness, really? Is the answer 1? It looks like that. Because, yeah, I mean, 4y square over 4y square, the answer is indeed 1. So d square y over dx square at the point P is just 1. Perfect. Okay. Inverse trig, guys, inverse trig. We need to find the equation of the tangent line to the tangent line means point and a slope, and unfortunately they have only given us the value of x. So they want us to find y and the slope. So derivative. Let's find f prime x first. So f prime x will be, the formula is 1 over square root of 1 minus inside guy's square times the derivative of inside thing, which is just 5. And if I put x as negative root 3 over 10 over here, so that's going to look like 5 over square root of 1 minus 5 times negative root 3, or I can just put the negative here and multiply this by root 3 over 10 square. So this will be 5 over square root of 1 minus 5 times 2 is 10, right? And the square of negative root 3 over 2 is just 3 over 4, because square of negative is anyway positive. I hope you understand. 1 minus 3 over 4 is 1 over 4, and the root of 1 over 4 is 1 over 2, and 5 over 1 over 2 is 10. So that's the slope. I need to find its y coordinate as well. So it's just that I'll just plug in x as negative root 3 over 10 in the equation. So root 3 over 10. So this will look like sine inverse negative root 3 over 2. Now, if you guys think that the answer is um, uh, 4 pi over 3, you're wrong. And that's the mistake that usually students do over here. Remember that sine inverse, when inside thing is negative, it returns a negative answer or negative angle. So the answer is negative pi over 3. Just be careful. So the equation of the tangent line will be y minus pi over 3 or plus pi over 3 is equal to slope, which is 10, times x minus root 3 over 10 or plus root 3 over 10. So that is the equation of the tangent line. All right. E to the x multiplied by secant inverse x. So that's the product rule, of course. I'm going to use dy over dx will be equal to e to the x remains as it is. Derivative of secant inverse x is 1 over absolute value of x square root of x square minus 1 plus secant inverse x as it is, and derivative of x e to the x is, it's like the most innocent function, right? It's just again e to the x. So the answer is e to the x. Honestly, I cannot really do much. I'll just rewrite probably in a more, it will look a little more aesthetic probably, but yeah, I cannot really do much about this guy. So that should be my final answer. That's what I'm going to mark. All right, derivative of inverse. Usually students are confused about this concept. Try to explain my best here. Uh, G and G prime are given at various values of x, and h is the inverse of G, right? H is the inverse of G. So what is the derivative of h at negative 1? This means that derivative of h at negative 1 is as good as asking derivative of the inverse of g, derivative of the inverse of g at negative 1, right? Because h is g inverse. So I just replace this h with g inverse. And the formula is the derivative of inverse of a function is 1 over derivative of the original function at g inverse of that point. So it will be 1 over g inverse 1 over g prime of. Now g inverse negative 1 is basically we are looking for y value in the g table, because g inverse minus 1 is original function's y value. So I can locate negative 1 over here in g. And what is its corresponding x value? That's negative 5. So I'm looking for g prime 5 basically. And what is g prime 5? Isn't that, sorry, g prime negative 5? Isn't that negative 3? Because g prime at negative 5 is negative 3. So the answer is 1 over negative 3. Likewise, over here we have, what is the equation of the tangent line to h at negative 1? Now be careful. Tangent line at negative 1 means, once again, the negative 1 point is on the inverse. And we already have its slope. The slope is negative 1 over 3. So the point is negative 1 comma, negative 1 is original function's y value, and the original function's x value is negative 5, which will become inverse's y value. The slope is negative 1 over 3. So the equation of the tangent line will be y minus minus 5. So can't I just write plus 5 equal to slope, which is negative 1 over 3 times x minus minus 1, or x plus 1 over here. That should be our answer. Then they're asking what is the equation of the line that is normal to the curve at negative 3. So for normal, unfortunately, first I need to find the equation of the tangent or the slope of h at negative 3. So once again, if I'm looking for h prime negative 3, so basically I'm looking for g inverse prime of negative 3, which is 1 over g prime of g inverse negative 3. G inverse negative 3, as you can notice, is this is the y value. So its corresponding x value will be negative 4. So it will be 1 over g prime negative 4. And negative 4, g prime negative 4 is negative 5. So it's 1 over negative 5. But be careful, they're asking for the equation of the normal, which is negative reciprocal of this guy. Negative reciprocal will just be 5. And the point is negative 3 comma negative 4, right? Negative 3 comma negative, sorry, negative 3 comma negative 4, as we can see over here. So the equation of the tangent line will be y minus y1, so plus 4, equal to 5 times x minus minus 3, or plus 3. Right, guys, another similar question. Fx is g inverse x and gx is given. We need to find what is f prime of negative 10. I know that f is g inverse, so f prime of negative 10 can be written as g inverse prime of negative 10, which can be written as 1 over g prime of g inverse negative 10. And g inverse negative 10 we already know, right? Because g of negative 2 is negative 10. So g inverse of negative 10 is negative 2. So 1 over g prime of negative 2. And unfortunately, I don't know g prime, but I know g. I can easily differentiate this. So g prime is going to be, I think, 6x square minus 2x minus 5. So g prime of negative 2 is going to be negative 2 square is 4. 6 times 4 is 24. Negative 2, right? Negative 2 times negative 2 is positive 4, and this is negative 5. So this will be 28 minus 5, which is 23. So this will be 1 over 23. And that should be my answer, right? That should be my answer. That's what I'm looking for. Okay. We are given a function and its derivatives value at the point 0 and 1. And you need to find the first derivative of this guy. Let's call this guy gx. So g prime x at 0 is going to be, first let's find g prime. So I think I need to use a quotient rule. So I'll do low square 2 plus cosine x square. Low d high, derivative of f is f prime, minus high, which is f prime x, and sorry, fx, times the derivative of low is derivative of 2 is 0 and cos is minus sine, so minus sine x. And all I need to do is just plug in 0 everywhere. So this is going to look like what? Cos 0, 2 plus cos 0 is 1, 2 plus 1 is 3, then f prime 0, and then f 0. It doesn't matter because sine of 0 is 0, so that thing is gone. Again, cos 0 is 1, so 2 plus 1 whole square. F prime 0, this is 0, this is f prime, which is just obviously 2, negative 2 over here. So 3 times negative 2, this guy is 0, over 3 square is 9. So the answer is negative 6 over 9, which is negative 2 over 3. So that's g prime x, and that should be g prime 0 to be precise, and that should be our answer. Finally, we have this last question. So we need to find, this is a composite function or nested functions. So we are given kx as a composition, and we need to find k prime x and then k prime pi over 4. So k prime x is going to be first the derivative of the outside guy, which is g prime, and inside guy remains as it is. And then we differentiate f, which is f prime x. So we know g, we don't know g prime. Obviously, we need to find that. So what is f prime x? Obviously, derivative of sine square x using the chain rule, because sine square x can be written as sine x square. So it will be 2 times sine x, and then derivative of sine x is cos x. What is g prime x? That's going to be, of course, just 2x. So g prime of fx will be just 2 times of fx, right? So here I'm going to write 2 times of fx. I hope you understand. I just replaced this g prime of fx by 2fx, and then f prime x by 2 sine x cos x. That's basically I'm borrowing from here. And fx is sine square x. So 2 times sine square x times 2 sine x cos x. 2 times 2 is 4, sine square x times sine x is sine cube x, and cos x is just as it is. So k prime x is this. And then in b, I just have to replace x by pi over 4. So we know that sine of pi over 4 is root 2 over 2, and then cube, and cos is also root 2 over 2. Root 2 over 2 cube times root 2 over 2 is basically root 2 over 2 raised to 4. And then root 2 over 2 can be written as 1 over root 2 raised to 4. And root 2 raised to 4 is basically root 2 times root 2 times root 2 times root 2. Root 2 times root 2 times root 2 times root 2. This is 2, this is 2. 2 times 2 is 4. So this is 4 times 1 over 4. So the answer is just 1. Right, guys, I hope all these questions made sense to you. If you like this video, please like and subscribe, share it with your friends. It will also help my channel. Stay tuned, by the way. I'll be posting the videos of the other units as well, so you might benefit if you hit the subscribe button and the notification thing. And if you need private tutoring, feel free to reach out. Thank you.